Hi, we're here back at the digital job site working on steps in the right direction, which will show the steps to use to calculate things like framing, clearances, stairwell opening, etc. In the first session we cleaned up some of this geometry. Now we'll just move forward and do some layout here. And the nice thing about doing this digitally is that I can just hide some of these elements, get them out of the way, and we can just bring them back at any time when they become relevant. Except I deleted our angle line, which I wanted. So I'm just going to trace that angle line now. When I hide this geometry, we will maintain the line for that stair nosing. That back button is awesome. I wish I could do that out in the real world. Anyways, we're just going to hide these, and then just going to reestablish this line of nosing dotted line here. There we go. I can get rid of that little line and delete that. Erase this line. Okay, there's our line of nosing, and just for the purposes of doing this drawing as an example, the code, as far as I know, is a 6'8" minimum headroom, and that is measured from the line of nosing. Our dotted line is the line of nosing. I'm measuring vertically 6'8" off that line. I drew this in the blue direction, so I know that's vertical. All right. Now for our headroom, we have to have, when you walk down this set of stairs, the headroom has to be a minimum of 6'8" perpendicular to that, which is, let's see what this is, and that's a 5'4" almost, and as long as those two lines are parallel, if nothing encroaches on this line, then it's gonna meet our vertical dimension at any point, 6'8". Okay, so we got that, and now if this was a floor truss system, we would want to frame the floor trusses on the opposite side. And so I'm just going to throw in a couple dimension or guidelines here, and that gives us the height of the floor truss. We assumed at one point that that was an 18-inch truss. Doesn't matter if it's a joist or a TJI. The dimensions that pertain to your particular condition are the only thing that matters. All right. So if we draw back here, we want to make sure that after the stairwell opening, if it's going to get sheetrock, after it's sheetrock, that there is enough headroom afterwards. I don't want to get on the wrong side of a building inspector. So I'm just going to pretend we're going to have 5/8 sheetrock on the ceiling, and in the stairwell, maybe in your case it's only 1/2 inch. It's not that important what it is, as long as you lay out the dimensions you're going to want. All right, so we're just going to draw what'll end up representing a floor truss over here. Simple enough. We'll do like we did on the other side and offset this 1.5 inches. Oops, wrong tool there. Offset tool, not the move tool. 1.5, get rid of this middle part. Okay, so here we have just going to group that real quick to get it so it'll behave. And what I'm doing here is establishing where our finished surfaces will be if we put 5/8 sheetrock onto the floor truss. So if this is making sense, this point right here would represent the corner bead. of a sheetrocked floor truss. So I'm just going to move it over until that point touches the line of nosing right at that spot. With all that, what this is telling us is that if we're in the framing stages of this project, we would, from that truss, the face of that truss to the face of this truss is, survey says 10 foot 11 and 29/32. Sounds an awful lot like 11 feet to me. And so you can see by putting this geometry in, we can calculate what the framing dimension is that will account for our stair stringer, the hanger, the nosing, the risers, the treads, the whole business. And on this side, sheetrock and on a floor truss. And you can come up with a dimension before you ever even go out to the job site. You know what clearance you need between there. So it's pretty handy to be able to do this ahead of time, make adjustments accordingly, and go from there. So I'm going to stop this at this point, and then we'll fill in the stairway on the third part of this video series.